Folks, this panel is, in my view, one of the most important that you will see. The railroad industry, particularly the Class 1s, has been steadily losing market share. It's just small, it's only 1 or 2% a year, but you keep doing that for a period of years and slowly you lose your position. Now, what is the primary focus of the shipper? Not the railroad, the shipper. It is so difficult to do business with a railroad. The shipper has one basic question. Where is my car? He wants to know where his car is and when it's going to be delivered. Now, I used to be in the trucking business as well, and we had little devices, they're about this big, that you just put into each trailer, and it is a responsive GPS location device. You ping it and it tells you exactly where the trailer is. Now, the railroad industry has something like 1.6 million cars. About half of them are privately owned, and they are wandering around and the shipper can't find them. Now, that's not entirely true. Big shippers have developed their own systems for locating cars and finding out where they are and where the content's in them. But I believe that for the industry to really prosper, we have to have the use of telematics. And these two gentlemen are going to tell you about what they are doing in the telematics field. They did this last year, or other representatives of their companies did this last year. And I hope in another year we'll review the progress that we have made. But giving the customer the tools to deal with a railroad. Now, there are other problems with railroads. Paperwork is a problem. The average shipper, when you face him with a bill of lading, says, "Good God, what is this?" Now, the railroad feels that it is important for legal reasons and also for operational reasons to have all of the details that are on a bill of lading. But to the shipper, this is a big problem. If he deals with a trucker, he just gives him a load, tells him where it's going to go, and he doesn't have to worry about it. So we somehow have to break through on that front, and it seems to me that telematics are the key to this. So we have here today two really leading proponents of this whole area. We have Dan Anderson, who is with Trinity Rail, Trinsight, and we have Ken Mannka, who represents Nexxiot, which has done a lot of the nuts and bolts that is necessary to make the system as a whole work. And so I'm going to ask each of them to talk for 10 or 15 minutes about the progress that they have made and the problems that they have encountered over the last year, because this is an ongoing saga and we have got to solve the problem. Dan, why don't you step up?
Thanks, Carl. Appreciate it. I did have some slides. We'll get those up in a sec. But Carl, thank you very much for the invitation to come back this year. Great new venue. Very excited to be here with everyone. And I do have some updates from last year as well. So that's exciting. Get to those in a bit. Let me see if I can. Which way do I point it? What move? Is there like a special move you have to do for this? Aha. All right, I got it. We're going to go back to the beginning because all good stories start at the beginning, right? All right, so I want to share with you, I want to give you a useful publication. It is something that we put together over the last year that I think will help you internal in your organizations. I've got a paper copy here, but there's also downloadable. I'll get to that in a little bit in here, but let me, before we do that, just give you a little introduction as to who I am and who Trinity Rail is and a brief update from where we were last year. So first of all, as Carl said, my name is Dan Anderson. I lead our customer strategy group at Trinity Rail. In my 8 years in the industry, I've gotten the privilege of working with our executive leadership and board to drive a strategy focused on industry growth. Carl said it best. We have a modal share problem in freight rail, and we need to work on that collectively across the industry. I've had the privilege of working on product innovation through industry coalitions like Rail Pulse. I've been involved with that since its founding, and repositioning Trinity Rail as a supply chain solution provider as opposed to just a manufacturer of rail cars. Trinity Rail is 9,215 dedicated rail industry professionals, serving over 700 customers. We operate 6 maintenance facilities in the United States for freight rail cars, 3 freight rail car manufacturing facilities in the United States and Mexico, and 4 professional offices across the North American continent. Our fleet of 141,000 owned and managed rail cars consists of 270 different rail car designs that moves 900 different commodities across the 5 major freight rail market segments that our industry serves: agriculture, chemicals, energy, consumer products, and construction and metals. The 2 big updates from last year is, first, last year on this panel I had the privilege of speaking with Corey Banks from Quasar. And as for any of those that follow the industry acutely know, we acquired Quasar, Trinity Rail did, in May of last year, adding their yard management capabilities that they had developed with their previous owner, Can-Do Rail, a short line in Canada, to our Trinsight portfolio. Trinsight is our logistics web application that ingests a lot of the great data that comes from sensors like Ken's at Nexxiot, but across the industry, and turns it into something that customers can drive decisions from and be more proactive about their rail supply chain. A recent acquisition that Trinity had was purchasing RSI Logistics, which is a third-party logistics provider in Michigan that is one of the biggest in the rail industry, helping customers to manage their supply chain from bill of lading to yard management to fleet management, as well as transloading capabilities across the eastern half of the United States and intermodal ISO tank capabilities in the Northwest. Those are the big updates from last year. I'd like to share with you some insights about how you can have these conversations internal at your organization. Before I do that, my lawyers tell me I have to say a few words, so let me just read them directly off the paper. I'd like to remind everyone that we'll be discussing forward-looking statements within the meaning of the Private Securities Litigation Reform Act of 1995. Actual results may differ materially from those projected in any forward-looking statements we make today. The factors that could cause our actual results to differ materially are discussed in the company's most recent 10-K and 10-Q filed with the SEC. My lawyers will be very happy, so I appreciate your indulgence in listening to that briefly. So it seems, as Carl said, Carl laid it out really well. I think, honestly, we could have just had you do this, Carl, and Ken and I could have sat back and you've got the pitch nailed, but I'm going to try my attempt here, which is that telematics is increasingly a growing conversation in the North American freight rail space. New words are being added to our vernacular in the industry: telematics, sensors, hubs, visibility, things that we weren't talking about before. But as we at Trinity Rail increasingly speak with customers and rail industry participants about the interest in railcar-based telematics, we've heard a reoccurring set of objections. So as Carl talked about, why isn't this taking off faster? Many of us probably use GPS, maybe specifically Waze on our way here. It's ubiquitous in our consumer life. Why is it not ubiquitous in the freight rail space? 2 major objections. One is, what about CLM, car location messages, and the data that railroads already provide about the location of rail cars? Isn't that enough? And the next is, isn't this more of a luxury than a necessity? What makes this more than just some cool technology that cutting-edge companies are implementing in their supply chains? What makes this relevant for me? Those are the 2 big areas of objection. I'm going to try to address them, but what we did at Trinity Rail is we partnered with the Boston Consulting Group to prepare a paper that you see on the right-hand side of the slide. And there's a QR code that'll repeat itself throughout the presentation that'll bring you to our website. You're welcome to download that paper, read it through. It's very insightful. What we did is worked with Boston Consulting Group, and they talked to our internal leaders, they talked to our customers, they talked to Rail Pulse, they talked to shippers, they talked to people throughout the industry and put together a case for rail's digital future so that we can repeat this conversation and the justification across the industry with these insights. Today I'm going to review those findings with you briefly, But as always, feel free to reach out to Trinity Rail or download that paper on our website at the QR code to have this conversation internal to you. I'd like to take one step back and double down on something that Carl said, which is, what is the problem we're trying to solve here, right? I love this conference because the advocacy is in its name, right? We all are advocates for rail. Why is rail not stealing more share from truck? It is a better mode of transportation. It is a safer, more efficient, more sustainable way to move freight in North America. So the BCG paper starts with an analysis of what's happened to modal share to really frame the problem. Rail's share of the market has shrunk from 2011 to 2020 from 51% all the way down to 37%. Meanwhile, truck share has grown from 49 to 63. This clouds the fact that there's been an absolute growth in the number of ton miles moved by truck, and the volumes moved by rail have remained fairly stagnant over that time, despite the broader economic improvement that we've had in the last decade. A lot of that has to do with coal. So we've broken out here coal's contribution to that modal share and the rest of rail commodities. You can see that the rest of rail has remained fairly steady during that time frame. It's really coal volumes for a variety of reasons. It's not like we're losing modal share. It's that other inputs into electrical generation are taking coal's place. But what this does demonstrate is that railroads and the industry more broadly have not done a very good job at replacing that volume. The authors assert, as I led with, that rail should be doing better. From an efficiency and sustainability standpoint, rail has a very compelling mode of transportation for anyone who operates a freight supply chain in North America. If you just move 10% of the freight that's shipped by the largest trucks to rail tomorrow, that would reduce greenhouse gas emissions in the United States alone by 17 million tons. That's the same as taking 3.4 million cars off the highways or planting 260 million trees. So what does this have to do with telematics, right? It helps us identify key pain points, specific pain points that railroads, shippers, and owners are having that can be addressed, at least in part, by real-time information about your rail supply chain. So the BCG paper really isolates the value streams into three key categories. The shippers, the individuals managing the supply chains, trying to move their goods and really their revenue from point A to point B. The railroads that are operating, moving the trains, and the railcar owners. As Carl said, a significant portion of the 1.6 million railcars in the North American network are not owned by the railroads. 54% are owned by lessors, like Trinity Rail, and another 20% are owned by shippers themselves. For shippers, many of the addressable pain points that drive them to pick other modes can be boiled down to uncertainty. How can you plan a supply chain around a mode that provides so little information and so much variability? This manifests as unexpected delays that can impact hiring and production at key shipper facilities. Uncertainty around payload conditions that can lead to lost revenue in the form of spoiled loads. And slower railcar cycles, which leads to excess railcar needs and excess cost. In each case, the lack of visibility into rail supply chains costs shippers time and money. For railroads, the addressable pain points in meeting new, larger opportunities is really about leaving operational leverage on the table. Whether it's poor pipeline reporting, slow handoffs, or congestion, these black holes in the rail system today leave operational upside unrealized for many of the short line and Class 1 railroads across the continent. And for railcar owners like Trinity, pain points force more reactive fleet management in lieu of a more proactive approach. This can manifest as fleet maintenance based on mileage or time instead of condition. The authors in Trinity assert that based on this analysis, two things are true. One, these pain points can drive loads ideal for rail to other modes. Second, these pain points can, at least in part, be addressed by telematics. So let's go into how that might be true. How can telematics link up with some of these pain points and help to solve? So let me orient you with this table that's taken directly out of the piece that's elaborated on too at the QR code. Along the vertical axis on the left, you will see the three stakeholder groups we just talked about, and a fourth broader society group. These stakeholders are added to illuminate the benefits that are bestowed on groups external to the industry. Across the top, we've grouped the types of information that railcar-based telematics can generate into three broad categories: location, condition, and health. Location data would be the most basic information about where the car is in real time. Now, for those of you familiar with freight rail shipment, I'm sure you're thinking to yourself, well, isn't that what CLMs or car location messages do? For those that are unaware about what a CLM is, it's a signal from readers that are spread throughout the North American rail network that generate that signal when a certain rail car passes by. This is a 1980s technology implemented by and invested in by the railroads across North America. It already generates some location information that shippers can use to manage their fleets. However, in doing their research, BCG found the distance between these readers can vary tremendously. In some places, readers are 50 miles or less apart, and in other regions, there can be hundreds of miles between each reader. There are certain parts of the network that aren't outfitted with readers at all, like short lines, yards, and terminals. In this way, we are talking about just the most basic information data that could be attached to the rail car and not the infrastructure it traverses. Condition is the next category of data. It would speak to the condition of the payload. Rail cars themselves do not generate revenue for shippers. They do for lessors, but not for shippers. Instead, it is the shipper's product inside the car that matters to their business. Today, outside of refrigerated boxcars and some TIH-PIH fleets, little to no data about payload can be transmitted in transit. The last category of information is health information that would speak to the condition of the rail car. As sensor technology evolves, many aspects of the rail car could be monitored in real time, potentially allowing for condition-based maintenance and monitoring. The authors do a great job of walking through a number of the benefits highlighted in the boxes. So instead of going through each box on the table that's in the document, I'd like to focus on a specific story before I wrap up. So Trinity launched its Trinsight logistics platform with telematics capabilities back in 2021. And as demand for this type of data has grown, we've had the privilege of working with shippers to solve some unique logistical challenges. Recently, we were working with a chemical shipper in Canada to monitor their temperature-sensitive liquid product. You see, their product is used in consumer cosmetics and cannot freeze, or it becomes unusable. In December of last year, a railcar with over $800,000 of product was making a trip from Alberta to New Orleans. We had outfitted this car and several others in the train set with a GPS locator and a thermometer as a test case for the shipper. It just so happened that on this cold December day, this one particular rail car missed its switch in the northern United States. Because the shipper was receiving real-time location information from that car and several other tank cars in the same train set, the shipper was alerted to the miss almost instantly. The shipper alerted their carrier, and the car ended up sitting in the yard. As the temperature outside the car began to fall, the temperature of the commodity began to fall as well. The shipper was able to keep the railroad informed in real time about both the location of the car and the increasing threat of payload spoilage if it reached 32 degrees Fahrenheit. The railroad made the switch well before the product froze, and the product arrived at the shipper's customer without any spoilage. As an additional benefit, the real-time feed of temperature data throughout the trip allowed the shipper to prove to their customer that the product never reached freezing and therefore avoided waste. There are countless other examples of where real-time information can solve unique and specific supply chain challenges for shippers. Now, as with any technology, innovation can take time, and while Ken's Nexxiot group is on the forefront of giving us new enhanced insights from the sensors that they're providing, as well as many other providers, this diagram from the author does a great job of laying out a view of how the industry is moving through various use cases. Some of the initial use cases being tested today are real-time location. Enhanced estimated time of arrival is a key topic, and more data is necessary to continue to enhance it. But BCG found that our enhanced ETA, based upon the combination of CLM and GPS data, is already 25% more accurate than the standard CLM ETAs that are provided to shippers today. A few of the other near-term use cases are impact detection, temperature, as I mentioned in my example, door hatch open close, and handbrake on off. Keep in mind that this is dynamic, though, and as more use cases arise, as technology advances, and as shipper demand becomes more diverse, the state of these use cases may change, and economics will drive the next set of use cases to be delivered. So I hope you're as excited about the future state of rail as I am. I think this movement could make a huge difference in the value proposition that freight rail offers shippers in North America. However, I must stress that it's going to take time. Right? The authors believe that it will take 10 to 15 years for full system adoption, but that doesn't mean we can't make progress in the meantime. Currently, we're doing one-off railcar applications, and this will evolve into applications of discrete fleets and discrete sites, which is right now imminent. This will grow into certain fleets in certain regions and certain pools that will begin to be outfitted as well. The question I have for all of you is, will you be one of the first movers? Will you advocate for this on the rail cars that you touch, whether it be on the freight or passenger side? So I'd like to end by saying thank you for paying attention and listening to this compelling message. I encourage you to download the paper, read it through, and make your own conclusions, and start having the conversations internal to you as to what real-time visibility can do in your supply chain. Thank you, and enjoy the rest of your conference.
Morning. It's still morning, right? So I don't have a PowerPoint. I won't go through anything. I'm here to tell you why you should do the things and how you're going to do them. And I brought show and tell, right? I've got the examples. So how do you get that data off the device is a Nexxiot product. But I guess I should go back and introduce myself as Ken Mannka. I'm EVP of Nexxiot. We're based out of McKinney, headquartered out of Zurich, Switzerland. We've been in the States for 5 years and have an office here mainly because of Dan and Trinity. It was our co-founder that, if you were here last year, he came and spoke, and he met them on stage in Indianapolis 7 years ago, and we opened up an office. So 3 years ago, April Fool's Day of 2020, after 25 years in the rail industry, I changed careers. I started selling technology to the railroad. Because when I heard about this product and I went through a 20-minute interview, an hour and 15 minutes later, I was still asking the questions I expect you to ask me later today. How, why, can you, when, how much does it cost? All those questions drove it to the point where I now run North American operations for Nexxiot. And we're driving the innovation, and I've been out speaking now for the past 8 weeks at conferences. I've seen many of you there. I've worked with some of you in this room, and I'll probably work with more of you as we go forward. But one of the things that Dan pointed out is when I go to speak, I carry 3 decks in my pocket. Because if I'm selling to a shipper, if I'm selling to a railroad, or I'm selling to a leaser, their use cases are all different. The unique thing about Nexxiot's products and this whole movement is we can solve all of them. And right now, I'd say we're in the infancy stages of digitalization where we're just shining the light right in the middle of the room. We're going after the low-hanging fruit. When the lights turn on and this whole room and every corner's lit up is when this is going to take hold and run forward. Because right now you still have a little bit of that push and pull. Do I want to solve car hire or do I want to solve demurrage? Because solve both of them, we're all on equal playing field, but if I only solve one of those use cases, it's probably going to hurt the other one. All right? Do I want fleet health for a leaser? Wheel, bearing, we all unfortunately watched NS's struggles lately with East Palestine, Ohio. Well, what about having a sensor that told you that car was going to fail 1,000 miles before it's failing? 2 months ago, we take it out of service and replace that bearing because we can predict that it's going to fail. And that's the future of this digitalization. The CLM data, everybody in here, if you're a railroad, you're aware what it does. You're also aware that people with fat fingers like mine at one point in my career may have manipulated that. Right? Looks better from my 5 o'clock report that that car and that train left earlier. So now you can't manipulate. a timestamp, GPS location. All the features that come, and we're not that unique when it comes to it, of me and my competitors, is everything's geofenced. When did that car arrive? I get an alert. When did it leave? I get an alert. From the yard inside to the switching, I get an alert. If it's moving and I have a handbrake sensor on it, I get an alert. In the recent trials, we've had 3 instances where a car's moving over 20 miles an hour with the handbrake on. We get an alert, stop the train, remove the handbrake. Now, the funny part of this story is that conductor, there was no handbrake on that train. Nope. But I can tell you from the data there absolutely was, because I can see it being applied. I can see it running applied. And then when the minute that train stops, which I now know, the handbrake comes off. But he'd tell you it wasn't on. Well, why? Because we have to change that culture of, well, they're going to fire me if I forgot to take that handbrake off. And what we really care about is that train did not derail because the handbrake was on. There was no tread buildup, there was no loss of wheel, there was no sliding wheels. All the things that we all know go bad when people don't comply with the rules, we're going to tell you before that situation occurs. So if you're familiar with S2045, some of the things you need to ask is, can this go on a car? Is it safe? So HAZLOC certification, Class 1, Div 2, I can go anywhere in any plant. Anywhere normal operations of rail cars go, this device can go, communicate on cellular networks, nothing goes boom. All our sensors meet the same specifications. I can tell you if your hatches are open, your doors are open, your handbrakes are on, and with this one, I can tell you if your car's loaded or empty and the percent. That's pretty good information. When you couple it with my location, I know that that car is there, it's empty, and what time it got emptied because it reads. So no more am I relying on paperwork or the tough books, which have been a great improvement in the rail industry, but now I have real-time data. We've crested at Nexxiot, we have over 250,000 of these devices deployed internationally on non-powered assets. As Carl mentioned, trucking is great, but you have a 7-pin, you have power. There's no 7-pin on a rail car. So you have to generate your power, and how do you do that, and how do you make it last? 40 years, 10-year waiver, 50 years, well, I can give you 10. I can give you 10 at a time with today's technology. How does it communicate? We've got a roaming partnership with 350 carriers internationally. So if there's cell service, odds are it's going to communicate. If it doesn't, it's just like the black box on that locomotive. It stores the data and it fills it in backwards. As soon as it grabs a signal, everything in this box, every geofence, every alert, every measurement, every trigger, downloads to the UI. So some of you are smaller companies. You don't have the money and the resources to develop your own UI, you use Dan's Trinsight. You use Nexxiot's Connect platform. If you're a bigger, what we call the white whales, and you have your own, we just send the data to you through an API. You put it in yours, it's branded for you, it doesn't matter. The things that matter are having these devices. If I can tell you when this was made, when it was put in the box, and when it was shipped, how do I not know where 130 tons of my product are? Any given day, 500 cars lost in Chicago. Today, 500 cars. How does that happen? Back in the 90s, when I was loading cars for a scrap dealer in Pittsburgh, Pennsylvania, he would send 3 in hopes that 2 made it to destination, because they would lose one, and by the time they found it, it's empty. He was donating to the local economy of Chicago. Well, now, you know where it is, you know if it's loaded, it's empty, and if it's secured correctly, all right? Because there's no AEI readers to tell you when you get off that main line where that car is. We're human, mistakes happen. This fixes a lot of those mistakes. It's basically now, that's all I prepared for you. I was here to answer questions, and Carl's going to ask us some. We're agnostic. We can take, if I don't own a sensor and you have one, come on, I'll pair it. And we use Bluetooth technology, IEEE. We can take anybody's sensors. I just left the short line last night and had 3 different sensor companies come up with new and interesting sensors that they want to pair. So as Dan said, 10 years integration, we're going to have sensors on everything. As Gene Savage from Trinity once told me, there's 32 sensors on a Caterpillar when it comes off the end of the line. How is there not one on a rail car? Now you've got CSX. If you watch Nexxiot on LinkedIn, CSX is out quitting cars, and TTX. But you got Joe Henricks that's coming out of Ford. How many sensors are in my Ford pickup truck the day I bought it? You can tell me everything I need to know, but I've got a rail car that can't tell me anything. So it is the wave of the future, and I think everybody in this room, if you're here listening, you're part of the plan to make this on every rail car.
It seems to me that Ken touched on one really critical point, and that is the information that they generate can be adapted to every shipper's individual computer system. This is a critical point that in the past, the railroad industry tended to want you to call them, and you were dependent on their system. But particularly mid-sized shippers already have their own supply chain tracking software, but they need inputs. And what Ken's company has done is developed a system where you can transmit this instantly to the shipper, the customer, the customer, the customer. That's the key thing that, unfortunately, the railroad industry has failed to address. The other thing is the first mile, last mile. I can't remember whether it was Dan or I think it was Dan that said sometimes the sensors that read the AEI tags are only 40 or 50 miles apart, but sometimes they're a couple hundred miles apart. That doesn't capture the last mile or the first mile, which in many cases, increasingly, is a function that is performed by a short line or an industrial switching company. So it is critical that this is a universal system that Nexxiot has devised, which can provide all different kinds of information that can fit into the customer's software. And that's a point that I can't stress strongly enough. Incidentally, we have had for at least 40 years electronic wheel inspections. A friend of mine developed it for the Burlington Northern back in the 80s. And that information, however, was tied to a specific point that the car was passing. Whereas what we now have is a dynamic presentation of what is happening to the health of the car. So these are really important points. A couple of thoughts that occur to me, Dan, is this. What does all of this cost, and who is going to pay for it? How is it paid for?
It's a good question, Carl. We talk, and Ken can comment on this too, because it all begins with the technology that he demonstrated for us all, which is you have to put something on the rail car that can A, generate insights, and then B, phone it home. And that comes with not only the initial investment in the actual equipment itself, but also in the telecommunication charges to keep that channel alive and well during the car's operation. So because about 75%, over 75% of the North American fleet is owned by either shippers or lessors, they're the ones that are responsible for outfitting the cars. They're the ones that are responsible for maintaining that communication hub and making the initial investment. How that gets divided between the lessor and the lessee, the shipper, it depends upon each individual lessors doing it differently and how they, and I think that's good, right? In these early days of a new technology, you want a divergence of ideas and models. And then, creative destruction will in the end win out, and we'll align on the best few models that end up sharing that value across the owner and the user.
Carl, if Ken and Dan are available for additional questions, we've kind of used up our allotted time here. If you're available to go to our chat room, which is across the way over here in room number 5, if anyone has specific questions for either of these two gentlemen in this extremely important topic, you may be able to meet with them and discuss that.
I want to thank both Ken and Dan for taking the time to appear here. I think this is a great opportunity for us to improve the whole rail system, and we do have to think of it as a vast network. And I should say in passing that Ken also operates, Nexxiot operates overseas as well. So you have information if you're, for instance, shipping a container from a place in Europe or a place in Africa, you can get the same information there if they are equipped with an Nexxiot device. Well, thank you very much, and we'll go on to the next program. The chat room is right back there. It's chat room 5, and if you just sit there, I bet you a few people will come in. Thank you.
Thank you very much, gentlemen.